Okay, we're ready to begin. This is Don Larson again. Welcome to those of you that just joined to our webinar today on the second part of a series on S1000D compliant illustrations. Our agenda for today is going to be the brief introduction. I'll go through the housekeeping rules. I'll give you a quick company overview. Then we'll go through the body of the presentation, the slide presentation, and there'll be a few demos in there. And then we'll wrap up with a summary and a Q&A, and then some closing information. For the duration of the webinar, all attendees will be muted. If you should experience any problems, though, use the little question box in your control panel there to let us know. We do have some product data sheets or handouts that you can drag and drop, little PDFs there in the little handout box. Post any questions that you have. Feel free to do them. Just post them as they come to mind during the webinar, and then at the end of the webinar, when we're wrapping up with the Q&A, we'll address those. And then if we should fail to get to all of them, we'll be sure to follow up with an email. Larson Software, it's a US company based in Houston, Texas. We were founded in 1984. We are a graphics technology company. We develop graphics software tools, both for users and for developers that want to embed the product in their software. We promote the use of CGM by providing a free CGM viewer called VisX Reader. That's on our website if you haven't already got that. We're the first developer of an HTML5 CGM viewer. That means that you don't require a plugin anymore to view CGMs in a browser. We're a member of the CGM Open Foundation. Larson's products are used they simplify the graphics workflow for technical publication professionals, tools for creating, maintaining, and deploying technical graphics. So with that said, I'm going to turn it back over to David Manick, and he's going to present the main part of this presentation.
Thank you, Don. Thank you for the introduction, and welcome to part two. So if you did miss part one, then you can always catch up online. We have all our webinars are recorded, so you can we'll give you the link when we send out the emails after today's presentation. So you'll get a link to the recording of this one and also to part one if you missed it. Part two is really the focus on intelligent graphics. The first one was really around kind of the guidelines for the illustration, the look and feel of the illustration and so forth. And we looked to a new file called the IMF as well, the ICN metadata file, which we'll discuss again briefly today as well. So welcome. Just a quick overview. If you're not familiar with the S1000D spec, I'm pretty sure that most of you are, but a brief intro to the specification. It was introduced in the 1980s, and the main concept was to hold information in a modular form, in other words, data modules, and you'll see that mentioned throughout this presentation, or DM is the abbreviation. So the objective really of the spec was to provide a more flexible method of managing and also publishing technical documentation. So the underpinning of the management is the CSDB, or the Common Source Database. Again, you'll see that mentioned. And also publishing probably lends itself more to an electronic manual, the actual modular form of the data. But you could still print traditionally to PDF if that's still a requirement. So today, S1000D, widely adopted and accepted globally. It's a standard method. Really a standard method of producing technical documentation. And graphics and multimedia are a critical part of the overall data that you will publish. So often graphics are not ignored, I would say, but not taken to the same degree as text is or XML, to that degree in explanations of how to use graphics and how they fit into the overall spec. So that's our expertise, and hopefully you can draw on that today. This particular webinar is split into 4 different topics. So interactivity is kind of the umbrella, but we also want to look at the CGM, which is still predominantly the 2D graphics file format, how you would connect the CGMs to the data modules. And also at the end, we're going to look at a bit around the work that's done around SVG, because that's becoming popular as a format, and we'll explain why. So on the right, you might see the particular chapters some of this information is drawn from. So you've got some reference there if you want to go back to the spec after today and just study these in detail. We wouldn't have time to go through all of these. We've been spending about 4 or 5 webinars. So I suggest you go back and look at the spec. Obviously, it's a very large document, but you can just focus on these particular ones where the graphics are involved. So the first one is topic is interactivity. So this is the chapter and the table of contents actually drawn from the spec. So you'll see there's navigation rules, use of hotspots, and so forth. So you're given a complete real guideline on the use of graphics and the introduction of hotspots. Not everybody uses hotspots, I think, within their graphics for navigation and so forth. And I think there's a kind of there's a good way of actually creating hotspots, but not everybody knows about it. And also there's an added complication that people shy away from. So hopefully today you get more confidence about using them and introducing them into your documentation. In the first part, we've talked a lot about the changes from in the specification of from 4.1 to 4.2. In these particular chapters, there's very little change, if any. So mainly kind of title changes of figures. That's the only things we've really found. So no big changes on this side, as opposed to the part 1, where there was quite a few different additions to the spec around the presentation of the graphic itself. So the use of hotspots and interactivity. There's a whole raft here of how you can use hotspots with your illustrations and with your text. So I like to call them reactive areas, where when you click on them, something happens. It reacts to your click. In the spec, they call it sensitive areas. So I think reactive is probably a better way of actually stating what they actually do. So these are all the different ways you can use linking of hotspots in a graphic. So you can have text in a data model to an area of an illustration. You could have text in a data model to multiple areas of an illustration. One area of an illustration to the text. So you can have a bi-directional link between the two. And one area of an illustration to another area of the same illustration. So you can have links between the actual graphics themselves. So it might be a click on a particular area that navigates you to a detail view. One area of an illustration to the area of another illustration. So it could actually take you and present a second illustration to you based on the first one. And one area of illustration to a separate data module. So so the illustration might be in a maintenance type environment. It might take you to a data module that's got an IPD in it, for instance, and that's the next one anyway. So the illustration to parts information. So these reactive areas, in my experience, are usually call-out numbers. That's predominantly where you see hotspotting at the moment, is illustrated parts information. And it can be the number itself, the call-out number, or it could be the actual part, which would be much more difficult to actually create if you wanted to create a hotspot of the part itself. So predominantly, from a cost point of view, it's usually call-out numbers that are the hotspot. So that was drawn from the spec, and so is this table here. So it just gives you some examples. Obviously, it doesn't give you examples of parts, but it gives you the examples of callouts of what that reactive area might look like. So usually the callout number itself, you click on that, and that would navigate you to one of the examples I gave you earlier. So this is a table taken straight from the specification itself. So we've got some very, very short demos. It might seem like I'm jumping around here, but I wanted to give you some examples of, say, viewing hotspots to begin with. So in this case here, we have a link with a hotspot. So I move over, say, number 4, and it's highlighting the table. So this isn't a data module, it's a HTML table, but it shows you the potential that you could actually have a link, a bidirectional link between the two. So you can see as I move over the hotspot, it highlights the table. So as I move over here. Also, if I click on the table, although it's not very visible, you'll see that this is surrounded by a red border now, number 2 and number 3. So there's that bidirectional link. And I can still work with the graphic in here, so I could zoom in and so forth and see that a bit in more detail. But the main thing is here, we have this sensitive area or reactive area on the screen, which is our hotspot, and that could be linked to the text, or it could link to another graphic, as all those different examples told us. So again, very short demo to begin with. And that's going to be the theme really as we go through, just to give you examples of what we're talking about, what I'm talking about during the webinar. So there's a whole actual chapter on hotspots itself. It's in Common Constructs Hotspots. So you'll see in here in the table of contents that there's passages on just a paragraph on the hotspot, on CGM itself, because CGM version 4 file can contain hotspots, and we'll look at that later on, and also about the XML companion file, which we'll also discuss. So I've just done this small kind of schematic just to give you an idea of the different files that can be involved. If you have hotspot information, it's potentially there's 4 different files that you might need, or say 3 at the most. But only really 2 are required for making the link between the 2 work, as we've just seen before, and that's the XML and the CGM. So these would be essential. You need both of these elements. There's also an optional element called a companion file. The one used predominantly up to now is it's called a .xcf. It is XML, although the extension doesn't belie that. But it is an XML file. So this would contain information pertaining to the CGM illustration, but in a separate file. So you could actually put more detail in there and keep it out of the illustration. But essentially, you need 2. You need the data module and the CGM. And then there's a new file that is potentially could replace the XCF file, and that's the IMF or ICN metadata file, which we discussed in more detail in the part 1. And we'll look at it briefly here as well. But again, that's an XML file, but it can contain much more information, as we'll see. So a bit more detail. So we have the data module itself, which is an XML file compliant to this spec. Usually, certainly in the US, the issue of the data module is usually 4.0 and above, certainly for recent projects. The CGM has to be inserted into that data module in where it belongs with the text or with the parts list. And it can contain hotspot information. It doesn't have to. It's not mandatory. So you don't have to include that in. But for your user, then you have really got a truly interactive manual text and graphics if you do that. So the XCF, as I mentioned, is a companion file. So it would actually have a companion illustration. So you'd have to have the companion file, which would link to that particular CGM graphic. One word on this is that the CGM viewer that you're using would need to support that companion file. So The majority of them do, but you just need to kind of double check that that is the case. The IMF file is the new technology introduced into 4.2 of the specification, and really gives you a lot more options for the metadata. So it gives you hotspots as the XCF does, but it also gives you a lot more opportunity to actually manage the graphic or the multimedia object. So it's not just about CGM, it's about anything that has an ICN code. The dependency on this is the support of third-party software. So you could create an IMF file, but then you're dependent on the CSDB, the common source database, supporting that format, so you could actually manage it, and also viewers as well to support that technology before you could make use of it. So it has just come out. We're taking a view on what we do at the moment on creating that particular file format. So as I mentioned earlier, you got that two components. You got the data module, and you've also got the graphic. And you can see here, this will be a common theme, that in the XML, we've got the hotspot, and then we've got its ID, hot001, which has to be unique in the graphic itself. And here we have the appropriate hotspot, hot001, with this is the ID. So that really creates that mapping between the two, between the text and the graphic. You also have the name element, which is really the call out itself. But the ID is the crucial thing here, that it's unique, and it will create that link between the two. Next we go to the XCF file. So the XCF is the XML file. That it is documented in the spec, and we'll talk about that in a second. But similar, it also has this unique ID. The ID name is different, but it actually maps to the CGM in the same way. So it's using that hot001 to actually map to that CGM. And it can also include other information like the region, and you see up here like a screen tip as well. So you'd have the screen tip, actually that's not the screen tip, but you could have a screen tip in here as well. This is visibility. You can turn the visibility of the hotspot on or off as well. So the XCF structure is actually documented in the S1000D spec. It's actually in that chapter. So it's chapter 7.32. It consists of five main structures. So the overall one is Web CGM Profile 2.1, but it's only a subset of the application structures are allowed in S1000D. So it doesn't contain the whole of the Web CGM spec. So just be careful that you only put in the allowed structures or allowed attributes. So hotspot, this will describe the attributes, the name, the region, and the view context. So this is allowed in the CGM. So you can have the name, obviously the ID has got to be there, the region, so where is it positioned on the graphic, and a view context would be its magnification, what viewer you're actually seeing, and that can be in the CGM. Additional attributes such as a screen tip, for instance, should really only be in a companion file. So bear that in mind. There could be an opportunity to put it into the CGM, but really it should be controlled by an external companion file. And this maps to that hotspot element in the same way as we saw with the graphic itself through that ID. There's also an opportunity in the XCF file to put in the standard linking elements with S1000D. So if you're familiar with the spec, a data module reference, an internal reference, and a catalog sequence number, which is really relevant to the illustrated parts data. So you can put that into the companion file as well. So you could, for instance, have a link or a hotspot within the graphic that links you directly to that other data module that we were talking about, or to a paragraph within the data module, or to the parts list itself. The final two here, I've not really seen these used, wasn't really aware of them. I'm not sure that they'd be applicable I think they're there as really as a standby or as something that you might use if you really need it. And one of the things that isn't mentioned in the spec is layer. So you can also have layers. And I'm not really clear if the spec allows you to use layers, but it's certainly something that's within the XCF. So that has great potential if you want to switch layers on and off. And that can be in that companion file as well. And then we come to the new IMF file, which potentially is a replacement to that XCF. It's obviously dependent on the support of software to do that. And again, this is the common theme, Hot 001. Again, keep coming back to this, that it's the same kind of ID that's in the graphic. The graphic hasn't changed, but depending on the companion file, the element that identifies it is different. As I said, refer back to part 1 for more information on the IMF, but you might see at the top here that it's a bit more like a data module, if you're familiar with that structure, where you can have an identification and status section for the graphic. So this where it gives it potential to be managed inside a database or a common source database. So a lot more control over the graphic. You potentially could have like a check-in, check-out. So you'll find the details on the IMF in the specification. It's only in 4.2 and the chapter 3927. And again, refer back to part 1. It can be used to manage the ICN multimedia objects. So it's not just for CGM files, for management of those. It could be anything. It could be a video. Anything that's not a data module has to have this ICN code and in theory managed in some way. So it becomes part of the overall deliverable. Yeah, and I really do see it as a potential replacement for the XCF file because it contains so much more potential information that you can add into it. It has all the kind of facets of the XCF, so it can again supports the standard linking mechanism within S1000D, such as internal ref and DMRef. And the question we're asking ourselves at the moment is where's best to create this file? We can certainly create XCF files, but the IMF can contain this other data that's not probably as graphic driven. So is it in the CGM editor, or is it in the XML editor, or is it a combination of both of them? So we're still really deciding what's the best route to support this format. So again, a short demo. I'm going to bring up VisX Edit here. So this was where we were talking about this hot here, that you can see the ID. So if I just click on this and modify, you can see that common theme there was the ID of the illustration. Or the hotspot. And then I've got this potential to create an XCF file. Very straightforward. I just export XCF and it creates this XML companion file in here. So very straightforward to create from the software. And what does it look like once we've created it? So here we've got a typical XCF. This one doesn't have a layer on it, but you can see again this ID is on here. This time this one has got a screen tip, and you can see this has got actually a foreign language. This is Spanish associated with this particular hotspot. So this is an ideal example of how perhaps the XCF file could be used. So you could have different companion files with different languages in, which the user then could leverage. So to show that, we've got an example here of the same illustration, but here we have a pull down menu. So I'm choosing English. When I choose English, it's swapping in the XCF file, the companion file, to show us the English screen tip. And then I've got the German. and then finally the one I just showed you, which is the Spanish. So that's a good example of how that companion file can be used. And you could potentially use the IMF file in the same way as the XCF. So the XCF was supporting that within this particular viewer here. So you can actually interrogate the companion file and bring that data through. And potentially you could have like the links that we spoke about to other data modules in there as well. So let's go back to the slide. Next we come to CGM. There's pretty much a whole chapter on that and under graphics around CGM. And interestingly, that CGM is still the only 2D graphics format that's documented within the S1000D specification. And there are 4 versions of CGM, but only version 4 can contain the hotspot information. CGM can be edited, published, and also viewed by the end user. So that's what it was really designed to do. So you have one file as your archive rather than multiple different formats. So it can be edited, it could be published to a PDF, but it also could be viewed in an electronic manual and the same file. So you're just really managing one file. But there's obviously a dependency on the software you have supporting CGM version 4. Well, it's not as common nowadays, but certainly CGM, you can find it in different software, but usually it's an older version of CGM. So you really need to have like an S1000D type of software to actually support that version. So with CGM, really, why was it chosen? I think mainly because of interoperability and the opportunities to validate the file, which some organizations do. So we've been talking about hotspots, and the ability to have the hotspot is given really by what they call the application structure of the CGM4 file. That's where that information is contained. And as I said, the metadata can be contained inside the CGM up to a certain point, but it also could be in this XML companion file. And as we mentioned again, S1000D provides some guidance on the metadata that you include with the CGM graphic. One of the key reasons that it was chosen was this kind of profile technology. So this really gives us the opportunity to save the file with a particular profile that could be validated by a third party, and gives us the opportunity to have an interoperable file. And we'll talk about interoperability a bit more when we talk about SVG. So actually WebCGM is the adopted profile of S1000D, or a subset of the whole profile WebCGM 2.1. So you can see how it's really described as a cascading profile. So there's the base, which is CGM itself, and then we got profiles on top of that, and finally the S1000D profile is the one that's compliant with the spec. So very, very short demo of this. This is the famous S1000D bike. It's a CGM file. I'm going to save it, and you can see we've got CGM chosen. We've got WebCGM, which is the full spec, and then we've got the subset, which is in this case S1000D 4.1. Do not believe there's any differences with 4.2, and then we go back to 4.0 and then 2.3 of S1 of the spec. And you can see other industries actually adopt the profile as well. So Air Transport Association, their ATA, and then we have the version 4 for the ATA, and then there's CALS, and then there's actually PIP, which is the profile for the oil and gas industry. The automotive industry use CGM as well, but they tend to use just the WebCGM profile. They don't have to conform to any particular specification, but they do use CGM as their graphic of choice. Again, down to interoperability, that's the key. So back to the next section, which is connection. So this is where we're going to connect really the graphic to the data module itself. Again, the chapters listed up here. The slides will be available, so don't concern yourself writing all these tremendously long chapter numbers down. So how do we get the CGM into the data module? So it's quite straightforward. We insert the graphic using the figure element. If there's multiple sheets, which there can be, in other words, there's say 4 sheets for the IPD, for the illustrated parts data, then you can easily create the 4 sheets inside the one figure by having multiple graphic elements. And you also notice this is the breakdown here. So we got figure, graphic, and then below that you have the hotspot information if there is any. And we'll demo an example of this. So just looking at the XML code, you'll see here we've just got a single illustration with the figure, the title, and the graphic, including within the figure tag. Below that we've got multiple, so you see the figure tag again, or element, and then we've got multiple graphic elements for the different sheets. So you'll see here it identifies 001, 0002, so that would be the different sheets. And then if there's hotspot information, this would also be in the XML, and we did see that earlier. So again, this is the code that you would see in the data module identifying the hotspot, and its application structure, bit of a mouthful, structure ident 001. So how do we get that graphic in there? So I'm just going to use, I'm using Arbitex for this, Arbitex editor from PTC. So what we've got here is our graphic within the data module. You can see the tag up here, and there's the figure, the title, and also the graphic. The thing is with these is that there is actually no hotspots. So these are just graphics without the hotspots. So we can see the tag on this side as well. So you got the figure and then the graphic. Okay, so let's just go down. So what I'm going to do is just insert a new graphic into it. I'm going to use that bike example. Just put my cursor in the right place, add the figure element. Okay, so I've just got a bit of an application here that helps me do that. So I can see the ICNs here, all the CGM graphics, and I can see the bicycle illustration. I can just preview that before I insert it. So you can see here the illustration. We could see the hotspots that are included on here. So okay, we're happy with that. We want to insert it at that particular place. And we can insert the graphic, and we can also see now that it's actually interrogated that graphic and it's put on. You can see all the hotspot IDs. We can actually choose if we want to. We don't want to include any hotspots, so we might want to exclude, say, 001. So I could deselect that. So what it's going to do is when I import it, it's going to bring in that hotspot information for me. So I don't actually put it in longhand. So it's going to insert the graphic and the hotspot, which is really useful. So import, it comes in, and there you can see here the hotspot tag has been created automatically, and the structure. If I just kind of move this over a bit, you should be able to see the ID and the name. So that's what it's brought in from the CGM file itself. When you're using a companion file, which would usually be used with some kind of viewer, you know, you're actually distributing information, then this would be obviously separate to that. You would be creating that from, at the moment, the XCF from what I showed you earlier from Vizx Edit. So that saves a lot of time. If you can imagine trying to actually enter this information longhand, it would take you quite a while. So that's quite a nice utility. Okay, so there, now we've created that link between the two, and then we can obviously view these, and we have the interactivity that we require. So the final part is, it might seem a bit disconnected, but I can assure you it isn't. And the reason we're talking about SVG is we've actually found a tremendous demand to convert CGM to SVG by our customer base. In saying that, not everybody's done it. So, and the main driver for that was the fact that in the browsers they're stopping support of ActiveX, and most of the CGM viewers on the market are based on ActiveX. We do have an alternative which is based on HTML5, no plugin required. So we give you the option really to do either. You can go to SVG if you wish, or you could stick with CGM and still have no plugin. So this could, when we actually saw this kind of move though with some of our customers to SVG, then we saw the potential that people might get this impression that SVG is the answer for your archive as well. And that quite quickly came to us quite an eye-opener, because SVG is, there's no profiles, there's no control. So we have a strategy based on what we've discovered from customers mainly for our export and import of SVG, and that's to optimize that import and export. So to give it a handle, we gave it the name Tech SVG, and explain a bit more about that in a second. So our strategy is to develop products that support these guidelines that we're kind of creating for SVG, and we're going to publish those. We're not going to keep them to ourselves. We're going to make those available, and our objective really is interoperability of SVG as far as that can go. I think it's also important to say at this stage that S1000D does not mention SVG at all. So, and we'll talk about that as we go along as well. So if you don't know about SVG, it's XML based, which is interesting because shows the data module. So that's an interesting fact about it, and also can give you a false sense of security, I think. There's a full version, and there's what they call the tiny version, which is really designed as a subset, a bit of a profile really, for the full specification for phones and so forth, so kind of mobile devices. But what we discovered is that an illustration, or a CGM as we know it, usually a technical illustration, only uses a small percentage of the attributes in that SVG specification. There's also a new version due of SVG. It's supposed to be this month, but I've not seen anything come out yet. Version 2. It doesn't really impact anything we've been doing to try and create kind of a profile for SVG. And as I said earlier, surprisingly, SVG is not mentioned in the spec at all. So, so I think that's quite. I think CGM is still what you would need to deliver to the customer if they needed the files along with the data modules. So just be aware of that. So this is what we found, is that, and this diagram I think explains it really well, is that there's the SVG full, and then there's the tiny, and then there's the SVG elements that are required by illustration. So it's a small subset of the elements actually in the SVG spec, which is enormous. So, and that's the reason that interoperability is such a challenge, because you could write pretty much any element in there that you like, and then your software has to read it in and read it out, or you might be getting it from other software that you can't read. And we've been doing a lot of testing, and some of the software exports SVG, also is able to import it, and it can't import its own exported SVG. So, and that's really because it's difficult to kind of have a return trip. So we've done a lot of testing around this, and it's really because of the fact that I've said earlier is that people want to actually make sure they can still present their graphics S1000D CGMs in an environment that doesn't require a plugin. So I might have given you the inkling of why we've done it already, and that's really because we want to make sure that when we create a file, it's standard, and that means that we can make our software compliant with that and make sure we can round trip and make sure the customer knows what they're getting. We can publish what elements they're getting, so if they have issues, then we can quickly discover where the problems might lie. So it's not that we're abandoning CGM. The opposite is true. What we see is that our customers also want SVG, so we want to help them achieve the same kind of quality they're getting now, and reliability, of course. So we will publish we've already written the paper. We are going to publish it. How we're going to do that, we're not quite sure at the moment. We will be at the user forum, S1000D user forum, in September. So come and see us if you want to discuss it in this face-to-face. So I've just done like a life cycle just to kind of encapsulate that. So SVG could come from various sources. So you'll see like Corel, Adobe Illustrator, a lot of other software, even some CAD software is beginning to support this format. But there is no real guidelines on how to write it out. So what we're looking is to consume that data, and then when we export it out, we have this tech SVG behind it, this profile, for want of a better word. So that then gives us this ability to round trip and gives us interoperability with our software. So final demo. Thank you for being patient. A lot going on. So within the VisX Edit now we can open an SVG file. So it just happens to be the same file that I've got open as a CGM. So we've been testing lots of different SVG inputs, so to try and get as good a result as possible. So I can open that up. So it is working well. All the elements are coming through, and we'll continue to develop this as we go along. And we can also save as SVG. So we do have that ability to open and save. Opening SVG is quite rare at the moment within software. As I've mentioned, a lot of software can export, but not a lot can open it. So that's why we want to make sure when we bring files back in that we have kind of not compliant files, but files that are constrained by what we're doing on export. So in summary, the spec, it does provide detailed guidance on creating and implementing intelligent graphics. And one thing just on the SVG, going back to SVG, it can also contain hotspots as well. And that's one of the things that we're really trying to standardize on more than anything. Creating and maintaining intelligent graphics and the associated XML, it can be a complex and time-consuming task, but hopefully you've seen today, hopefully you get some more confidence about doing that there are tools out there that help you in this task. CGM is still the required deliverable format for illustrations on projects. So not necessarily the file that can be viewed, so because that might not be the file that's delivered as part of a delivery, so the customer can then has the reassurance that he's got the data that he can continue using it. But certainly in a web environment, you could potentially deliver SVG, say for the IETM. The only caveat I would put on that is that you're still going to have to kind of create your own technology to view the SVG. So just be wary of that. And also you get another conversion process in place as well. You're going to have to convert CGMs to SVG. So that's why we're trying to create things that are consistent because anytime you convert something, there's a risk that something could get missed. And as I mentioned, SVG is a good mechanism for viewing the graphic in the web because it doesn't require a plugin. So that's one of the reasons I might not have mentioned that, but SVG doesn't require a plugin to actually view the graphic in a HTML page. Thus, that's why a lot of people have gone to that format to try and deliver their graphics on the web. And the final thing is that if you do use SVG, I would also recommend keep your CGM. There's a lot more tools out there for creating hotspots on CGM files. And then when you export them out, you should still get your hotspot information on there. So certainly wouldn't recommend SVG. Creating hotspots, say in Adobe Illustrator, and then trying to do that would be take you a tremendous amount of time. So we've got time for some questions. I might actually bring Don back in at this point. So let's just see if we have any questions. Okay. So does Larson provide any tools for auto hotspotting? So the answer is yes. The software I showed, VisXEdit, has its own hotspotting, auto hotspotting technology, but only really for individual files. And then we have another technology called VisX Transform that will do batches of files. We have quite a few customers who batch process files and add hotspots to them. Okay. Do you believe projects will use the IMF file for graphics? That's a good question. I think it's a bit early to actually make that call. It's obviously going to be dependent on the software supporting it, Viewer, ZSDB, editors. So difficult call. I certainly don't see it being probably going back in time. Perhaps in new projects, the spec doesn't say you have to use it. It's not mandatory, and but I could see it being used because it gives you a tighter control over the graphic for managing it, certainly. And probably Don, you might want to think about this one. Do you think CGM will be replaced by SVG? We certainly hope not, but in the S1000D specification, though, being more specific, do you see that happening?
Well, no, I don't see it being replaced. I mean, I see it being supplemented by it, or made as an alternative. There's some, like as you pointed out, for web deployment, there's certainly an advantage. It's searchable. So,
yeah, I probably would agree with that, that it might be eventually come into the spec as a supplement. I think the main difficulty is obviously cost, because a lot of people who work on the specification are unpaid. So I know when CGM was, I think Don was involved with the CGM going into the spec originally, there was a lot of work done voluntarily to actually document that. So, and that's a big concern nowadays, is that the people on the spec, are usually volunteers by their companies and so forth. So to introduce something brand new is always a challenge. So I think it's working as it is at the moment. So
yeah,
we'll see in the future.
Yeah, but there's also, as you pointed out in the webinar too, is that there is no standardization for interoperability, and hotspots is another thing. There's no standard in SVG. As a developer, I could find 5 different ways to represent a hotspot in an SVG, which means that an editor can't read it. It can't be interoperable. I just think the whole thing, the way that CGM came about was largely the development of the profile was within the an industry thing, whereas SVG is really universal to all industries, all technologies. So there was no focus on interoperability, and some of the specific requirements in a multi-vendor environment that you have, like the aerospace and defense industry. So there's two different ways that it all came about, and different. They're good at different things. So I, again, no, I don't see it being replaced, but it can be supplemented.
Okay. Yeah, I think that's a good take on it. Yeah, with SVG. So I think, like you said, with the hotspots, that is if you can imagine, everything is creating SVGs with different ways of creating hotspots, then you'd have to have multiple viewers or viewer having to support multiple ways of displaying the hotspot, which would be, obviously, for the developer would be a nightmare, but also for the company trying to use SVG, because they're never quite sure if the hotspot is actually done in the same way, and that's why we came up with Tech SVG. So thanks for that, Don, and thank you for the questions. So we just finally got some closing remarks. Our next event is the user forum. I mentioned it earlier. If you haven't registered yet, or if you're able to come, then you can still register. It's on from the 10th to the 13th of September, obviously this year. We've sent the slides will be available, but you can easily find it at the AIA Aerospace website if you want to actually attend. Next webinar we have not decided yet. The driver will probably be that event to give us some topics that we want to cover that seem to be high on the agenda. But it would be early October before our next webinar. But if you're on our database, then you will definitely receive an invite. So thank you for your attendance today. It's been great doing this series. Hopefully you can look at part 1 if you haven't already seen it, but you'll get an email with part 2 recording, and both recordings in the next day or so. So thank you very much, and we'll speak to you again soon. Thank you.